Okay, so this is page 78, number 14 from lesson 2.2's homework. Okay, this was lesson 2.2. Whoa, that's not a 2. Jeez. Okay, question says an architect's drawing shows a pipeline running diagonally under a basement floor from a floor drain to a sewer connection. The floor drain is at a point 2 meters east and 2 meters north of the southwest corner of the basement. The sewer connection is 10 meters east and 17 meters north of that same corner. The pipe costs $3.15 a meter, including tax. How much should the builder budget for pipe for the floor drain? Okay, so we have our y and our x-axis. We're going to need to graph this to get an idea of what we're doing. I need to get up to 17 and 10, so I'm going to get my graph to go by 2s. 8, 10, 12, 14, 16, 18, 20. So your graph's going to go by a scale of 2s every single grid point. Okay, so we've put up our grid. Now they've told us that the piping all starts from a certain corner of the house. They said this corner was the southwest corner. So we have our north, south, east, and west. Okay? Now, because they've told us it's from the southwest corner, what they're doing is they're taking all the measurements from one spot. So we're going to actually call the origin the southwest corner of the house. Okay? Sorry, not southwest. Why do I keep saying that? Southeast corner of the house. And then we're going to plot our points in reference to that. So the origin is the corner they speak of. And it says the floor drain is at a point 2 meters east. That means 2 to the right. This is the east direction. And 2 meters north. North is up. So 2 units up. So we go up 2 units and to the right 2 units. So here's the drain they speak of. And then they said the sewer connection is 10 meters east, which again is 10 units to the right. East is going to the right. And 17 meters north. 17 units up, which is north. So we go 10 units. 10 will be right here. 10 units to the east, and 17 falls in between. So it's going to be right there. So our next connection is right there on the graph. So we have them, and we'll plot the 2 points. 2 and 2. 10 and 17. Now, it says that the pipe costs $3.15 a meter, and they need to connect these 2 points. So they need to make piping from our first coordinate to our second. And we're going to call that coordinate A and B. So this was our coordinate A. This is coordinate B. And they want to know how long this pipe is and then how much it's going to cost us. So in that case, we're using our distance formula, which we learned the other day. D was equal to the root of x2 minus x1 squared plus y2 minus y1 squared. Okay? Let's put our 2 points down. Point A was at 2 and 2. And point B was at 10 and 17. Now I'm going to call point A my first point, so that'll be my x1, y1. And point B will be my second point, so x2, y2. And we're going to plug this into the formula to find the distance of this line. D is equal to the root. x2 is 10. Subtract x1 is 2. y2 is 17. Subtract y1 is 2. Squared. We solve for the brackets. 10 minus 2 is 8 squared plus 17 minus 2 is 15 squared. D equals 8 squared is 64. 15, I don't know off the top of my head. 225. Okay? From there, we add the 2 numbers together. We're looking for the root of 289. And our distance, we find the square root of 289. 17 on the dot. So we've now discovered that the distance from point A to point B is 17, and because the units we were in was meters, that's the distance from A to B. But they also told us that the cost was $13.15 a meter. So cost of piping was $3.15 per meter. We have 17 meters, so our cost will be equal to 315 times, and we'll say M for the amount of meters. Okay? So C will equal 315 times the number 17, which will give us our actual cost for the piping. 17 times 3.15 equals 53.55. So they need to budget $53.55 in order to pay for the piping for the floor drain.